Okay, I want to explain how we would go through the process of finding the volume of this triangular pyramid. So the shape of the base is an equilateral triangle. If we look at the information that's given to us in the picture, that 10 centimeters would represent the slant height of the pyramid. It does not represent the height of the pyramid. The height would have been a vertical line that is perpendicular to the base. So like this. This would have been the actual height versus 10, which represents the slant height. So if we look at the formula that we would use to calculate the volume of this pyramid, we would want to find 1/3 of the area of the base times the height. So the shape of our base is a triangle. We could use the area formula for a triangle, which is 1/2 base times height. Or we could use the formula for a regular polygon, which would have been 1/2 times the apothem times the perimeter. Since it's a triangle, I'm just going to go ahead and use 1/2 the base times the height. And then this variable h is representing the actual vertical height of our pyramid here, and I'm going to write that in red just because I want us to notice that there's a difference in the height h variable for the area of a triangle. So this red h is representing the height of the actual pyramid. Okay, so let's figure out what the height would be of this pyramid, because that's the tricky part here. So what you would do is just imagine that we are creating a right triangle right here, and this right triangle is made up of the slant height, which is 10 centimeters as the hypotenuse, and then our height is one of the legs, which is the height of the pyramid, and then this bottom side right here would represent the apothem of the triangle, the equilateral triangle that we have. So I'm just going to represent that with the variable a. So we need to figure out what the apothem is of the equilateral triangle. So let me draw this equilateral triangle. And our apothem is going to be the distance from the center of that triangle to one of the sides at a perpendicular angle, at a 90-degree angle. So here's the apothem. And we can calculate the apothem by looking at the information that's given to us. So if we have an equilateral triangle and all the sides are 6, that means from here to here would be 3 centimeters. And if we think about this being a right triangle, I know that this angle right here is going to be 60 degrees. Man, I drew this pretty tiny. So we know that that's 60 degrees because, let me just show you here, if we were to create triangles within this triangle, each of these angles would be 120 degrees. So then if I bisect it, that angle would be 60 degrees. And then what I'm going to use is the special right triangle relationship that we know. So if this is our 60-degree angle, the 60-degree angle is the side that is opposite from the 30-degree angle, just multiplied by the square root of 3. And then the hypotenuse would have been 2 times the side that's opposite from the 30-degree angle. So that means that this side right here matches here, and we're saying that that's 3. If I go through some algebra steps here, I can figure out that my apothem would be the square root of 3. because what I do is I divide this by the square root of 3 on both sides, and then what I would do is I would multiply by the square root of 3 over the square root of 3. This becomes 3 times the square root of 3 over 3. The 3 in the numerator cancels out with the 3 in the denominator, and we're left with the square root of 3 to represent our apothem. Okay, so I'm going to go ahead and erase this little a that we had right here because we just solved and found out that that was the square root of 3. Okay, so now I'm going to use the Pythagorean theorem to solve for the height. So we have a squared plus b squared is equal to c squared. Let me replace some of the variables here. So instead of a squared, I'm going to represent that with the height that we're looking for, plus the other leg, that is the square root of 3, is equal to my hypotenuse squared. Okay, so I have h squared plus 3 is equal to 100. I'm going to do some subtraction to get 97. Then I want to take the square root. So the height of my pyramid is the square root of 97. So I'm going to write that right here. And let me fill in the rest of my equation here. So we have 1/3 times area of the base, which is a triangle, times the height. Now let's calculate the area of our triangle. So there's a lot of different ways we could calculate the area of the base, which is, let me just go ahead and highlight the base so we know what we're looking at. This is the base of our pyramid, and it's an equilateral triangle. So all of these sides are 6. Okay, so my height would be, if it's an equilateral triangle, that means all 3 of my angles are 60 degrees. So that means that the height, if we know that this is bisected to be 3, the height of the actual equilateral triangle is going to be 3 times the square root of 3. All right, now I'm going to go through the process of replacing the variables that we have here. So we have 1/3 times 1/2, times the base, here's the base of our equilateral triangle, 6, times the height of my equilateral triangle, which we just found to be 3 times the square root of 3, and times the square root of 97. Okay. So let's do some algebra here. Whenever I'm multiplying my fractions, you multiply the numerator times the denominator. So this becomes 1/6 times 6 times 3 times the square root of 3 times the square root of 97. These 6's cancel out. So now I have 3 times the square root of 3 times the square root of 97. If we were to leave our answer in radical form so that we're not like converting this into a decimal, our answer would be 3 times the square root of 291 cubic centimeters. And if we convert that into a decimal, just for fun, that's about 51.18 cubic centimeters. Well, that was fun.